Sam here with jbugs.com. In our last video, we finished the assembly of a short block for our 1800cc stroker engine build for our 1971 Eurolux Super Beetle. With our engine taking shape, we'll get started on the top end by test fitting our pistons and cylinders, setting the deck height, and most importantly, setting the compression ratio for our engine. This step is often overlooked but crucial to the power and performance of an engine. Higher compression produces more output, but the byproduct of that is heat. On the other hand, if the compression is too low, the engine won't be efficient and actually ends up wasting fuel. Typically in VW engines, somewhere between 7 and 8.5 to 1 is the norm. We're going to set our engine at about 8.25 to 1 towards the performance side of the spectrum. The top end assembly begins by coating the ends of threads of our head studs with aviation sealant and threading them into the engine case. Our 1971 engine has a deep stud at the number 3 cylinder, so the top back threads at the number 3 and the 8 lower threads all use the longest studs. The top inner studs are the shortest, and the other 3 remaining top outer studs are the middle length. The studs are threaded in by hand whenever possible. A pair of vice grips can be used gently otherwise, and the studs are not over-tightened or bottom out in the engine case. Next, we'll get our thick wall 88mm pistons and cylinders pulled apart and cleaned for test fitting. The cylinders are somewhat unique. At the top, they are extremely thick and require the use of heads bored out for 90.5 cylinders. At the case, though, they're very thin. Since most of the load, pressure, and heat is at the head, not at the case, the pistons are actually a good alternative for those who are looking for more displacement and performance out of a stock 1600cc block. The pistons are pushed out of the cylinders, the rings are all pulled off, and the pistons and cylinders are cleaned. At the engine stand, we rotate the engine so that the number 3/4 side is at the top, and lube up and test fit a wrist pin into the number 3 connecting rod. It's removed, then a piston is placed over the connecting rod, and a lube cylinder is slid onto the head studs, over the piston, and down into place under the engine. With the crankshaft rotated to top dead center for cylinder 3, we can see that the piston sticks out past the edge of the cylinder because of our longer stroke crankshaft. Cylinder shims will be used to space the cylinder away from the case. We rotate the crank to make sure the piston clears the crank, and the crank stops. We pull the cylinder up and see that the crankshaft is hitting the skirt of the piston. This isn't out of the ordinary when using a stroker crankshaft, and there are a couple ways of clearancing the piston, so we pull off the cylinder, the wrist pin, and the piston. One way of clearancing would be to notch the skirt to allow the piston to clear the crankshaft. The other way, which we go with, is to cut the skirt clear. We measure the distance from the edge of the crankshaft at the bottom dead center point to the bottom of the hole for the connecting rod, and note the measurement. Then we measure that distance from the bottom center line of the wrist pin hole in our piston and mark the skirts to be cut there. What you do to one side of the piston, ideally you'll do to the other to keep the piston balanced. And what you do to one piston, do to the remaining pistons to keep the engine and rotating assembly as balanced as possible. The skirts on both sides of the pistons are cut as close to equally as possible, noting our measurement. Then a sanding pad and scour pad on an air power angle grinder are used to even and smooth out the skirts and any rough edges on the piston. The pistons are cleaned up, and we reinstall a piston to a connecting rod to check that the engine rotates without the piston hitting the crank. With the pistons now clear of the crank, we can get on to setting our compression ratio and deck height. At our workbench, we have an MPG TV 2-cylinder head that is machined for 90.5, or in our case, thick wall 88mm cylinders. The head has 20% larger intake and exhaust ports than a stock head's, so it will flow better and make more power than a stock head. We chose a head with 40 by 35.5 stainless steel valves and dual valve springs. MP lists the CCs of the compression chamber at 58, which we want to confirm, and at the same time we'll show you how to CC your heads using a head CC measuring kit. We thread a 12mm long reach spark plug into the head, which is sitting level on our bench. Then we apply a ring of assembly lube around the outer edge of the appropriate size disc. 3 discs are included to fit 85.5, 90.5, and 94mm heads to provide a seal between the disc and the head. Next, we fill up the large syringe with water up to the 60cc line. Then we fill up the combustion chamber with water until there's no air remaining. We know that there is 2 cc's left in the syringe. 60 minus 2 gives us 58 cc's, confirming MP's measurements. Now we can use those known measurements in our online engine calculator at jbugs.com, and we enter the following factors. Our bore is 88 millimeters. The stroke is 74 millimeters. The deck height will be our variable, so we leave it blank. Our cylinder head volume is 58 cubic centimeters. We enter the compression ratio we want, 8.25. Then, clicking the deck height button below tells us that a deck height of 0.26 inches will give us the compression ratio we're looking for. Now knowing the deck height we want, at the engine, we set our number 3 cylinder to top dead center. We do all of our measurements and set the compression at number 3 as it runs hotter than the other cylinders, so we make sure that if nothing else, it is at our compression limit. The other 3 cylinders should be nearly identical to number 3, but there's no harm in verifying the rest of the cylinders if you'd like to be certain. A deck height measuring tool is set on top of the piston, which is sticking out past the end of the cylinder. And with a set of feeler gauges on the outer edge, we measure the gap between the top of the piston and the cylinder at 50 thousandths of an inch. We set 2 40 thousandths shim on top of the cylinder and reinstall the deck height tool. A feeler gauge is used on the inside edge of the tool, and we get 30 thousandths of clearance, which is closest to what we're looking for, as cylinder shims are only made in multiples of 10 thousandths. We'll use a copper shim between the cylinder and the head, which will compress a little bit and most likely get us very close to the 26 thousandths deck height and the compression ratio that we want. In prepping for our next step, and knowing that our 80 thousandths of shims will be used, we mock up the number 3 and 4 cylinders and pistons on our engine and install each of the cylinders with 2 40 thousandths steel shims between the case and each cylinder. We set our cylinder head in place and install washers and nuts at the inner 4 studs and snug down the nuts in preparation for our next step. We've thrown around a bunch of numbers today while setting our compression ratio, and next we'll be setting up the rocker geometry for our 1.4 to 1 ratio rockers. That is going to involve much more number crunching, so we'll pause for now. Stay tuned for our next video. In the meantime, check out our other how-to videos, and when it's time to order parts for your vintage VW, stop by jbugs.com.